Climate change is a long-term shift in temperature and weather conditions. These changes might have natural causes, such as through variations in the solar cycle, but these changes also may be driven by human activities. The learning objective in the upcoming two video lectures is to understand the physical principles behind global warming and climate change. What is the role of greenhouse gas emissions and what is the impact on climate change with reference to the different scenarios for CO2 emissions in the future? The last learning objective is to understand the need for an energy transition towards an energy infrastructure that is carbon neutral or even carbon negative. Human influence has warmed up the climate in the last 100 years at a rate that is unprecedented if you compare it to at least the last 2000 years. This is demonstrated in this figure I have adopted from the recent report on climate change 2021, the physical science basis from the Intergovernmental Panel on Climate Change, the IPCC. The graph shows the history of global surface temperature change over the last 2000 years. The gray line shows the global surface temperature reconstructed for the period from year 1 to 2000, and the black line shows the observed global surface temperature from 1850 to 2020. The global surface temperature has increased over the last 120 years with 1.1 degrees Celsius in reference to the period from 1850 to 1900. This figure is from the same report that shows changes in the global surface temperature over the past 170 years. The observed changes are represented by the black line. Then the black line is compared to the CMIP6 climate model. So CMIP stands for Coupled Model Intercomparison Project and consists out of simulation runs from around 100 distinct climate models. The simulation results of the temperature response to both human and natural drives is shown in brown. The simulation results to only natural drivers such as solar and volcanic activity are shown in green. Solid colored lines show the multi-model average and the colored shades show the very likely range of the simulations. The human factor is indeed needed to explain the enormous increase from the 1950. The previous and this figure demonstrate that human influence has warmed the climate at a rate that is unprecedented in at least the last 2000 years. To combat climate change and adapt to its effects, 196 countries adopted on December 12th in 2015 the Paris Agreement, which is a legally binding international treaty on climate change. It entered into force on November 4th in 2016. The goal of this Paris Agreement is to limit global warming to well below 2 degrees Celsius, preferably to 1.5 degrees Celsius compared to pre-industrial levels. To achieve this long-term temperature goal, countries aim to reach global peaking of greenhouse gases emissions as soon as possible to achieve a climate-neutral world by the mid-century. The Paris Agreement is a landmark in the multilateral climate change process because for the first time a binding agreement brings all nations into a common cause to undertake ambitious efforts to combat climate change and adapt to its effects. But what is the physical principle behind the unprecedented increase in surface temperature over the last 120 years? I will try to explain the physical principle using this simplified picture. Planet Earth is making orbits in space around the Sun. In principle, planet Earth is making its orbit in close to a vacuum space around the Sun. This means that the energy exchange between the system Earth and space is not based on thermal conductivity. But how does the total system, planet Earth, exchange energy with space? The exchange of energy between Earth and space is based on electromagnetic radiation. Later this week, we will discuss that objects with a temperature above absolute 0 point emit electromagnetic radiation. First, the electromagnetic radiation from the sun, which emits in the ultraviolet, visible, and infrared part of the spectrum, is incident on the atmosphere and surface of planet Earth. If not reflected, the solar energy can be absorbed by planet Earth. The incoming solar radiation has a heating effect. On the other hand, planet Earth emits electromagnetic radiation as well. However, planet Earth is doing this in the far infrared, as the surface of planet Earth is much cooler than of the sun, of course. Through this electromagnetic emission, energy and power is lost towards space, or in other words, the EM emission of planet Earth is simply a cooling effect. The energy balance of planet Earth is in equilibrium if the same amount of electromagnetic power is coming in as is going out. Heating and cooling of the planet Earth is in balance. This is the case if global temperature remains the same over time. However, since the Industrial Revolution, human activity has resulted in extra emissions of greenhouse gases like carbon dioxide. The chemical formula of carbon dioxide is CO2. CO2 is formed by the consumption and burning of fossil fuels. Part of the extra emitted CO2 remains in the atmosphere. Greenhouse gases like carbon dioxide absorb in the far spectral range that partly overlaps the spectral range of the electromagnetic radiation that cools planet Earth. With other words, the extra CO2 in the atmosphere acts like a blanket and blocks a small fraction of the Earth's radiation into space in the far infrared. As a result, the power going out becomes smaller. The cooling is reduced. How much is this difference? Dedicated measurements using satellites over the last decades show that on average a solar power per area of 340 watts per square meters is incident and electromagnetic power per area of 340 watts per square meters is emitted into space. However, a subtle energy imbalance between incoming and outgoing radiation has been observed over the last 50 years, which is referred to as a positive radiative forcing expressed in power per area, so watts per square meters. From the period from 1971 to 2005, the radiative forcing has been on average plus 0.5 watt per square meters. In other words, 0.5 watt per square meters more radiation power is coming in than going out of system Earth. In the period from 2006 until 2018, the energy imbalance increased to a radiative forcing of plus 0.79 watts per square meters. Although these numbers look very small in reference to the total incoming and outgoing radiations, these numbers are only 0.25% of the total irradiance going in and out. It is still sufficient to cause the temperatures to increase of the oceans and surface temperature as observed. You can do that with a simple back on the envelope calculations. The most dominant greenhouse gas is, by the way, carbon dioxide, followed by methane. In the next video lecture, we will look in our CO2 emissions and its impact on the climate of planet Earth. So see you back in the next video lecture.